In order to evaluate E in an expression, we can use the calculator. And I've got two calculators I'm going to use as examples. And the example I'm going to use is e to the negative 2. How would we evaluate that using a calculator? So the first calculator I'm going to use is a TI 30XA, which looks like this. And for that calculator, the process that we have to use is we have to put this exponent first. So we punch in the 2, and then we have to do the change sign. And the change sign is this key here. Then we do the second and the e to the x key here, and then we hit enter. So again, the steps which I've outlined here. First we put the 2 in, then we look for the change sign button, not the minus operation, the change sign. Then we hit the key. In this case it's a yellow key, it might be some other color depending on the calculator, but a second key and then the e to the x key, and then we hit enter, and then we get the solution, which is 0.135. 0.135. It's irrational, so it goes on. 0.135, 335, etc. Alright, now the second thing I want to do is to evaluate that using a TI-83. And for the TI-83, the first thing we do is the second function and the e to the x. And so on that we'd have the second and the e to the x down here. Now we put in the change sign down here and the 2, the exponent. Then we close parentheses and then we hit enter. And then we get 0.135, the same number. 0.135, 335, etc. So here are two ways that we can evaluate an expression with E in it using calculators. Another topic for natural base would be the natural base exponential function. And it would take the form of a e to the rx. And if a is positive and r is positive, then we have a growth function, exponential growth. If a is positive and r is negative, we have a decay, exponential decay function. So here we have the natural base exponential function model. Another way to say this would be, is a greater than 0 and r is greater than 0. So a is positive, r is positive. Here we can say a is greater than 0, and if r were less than 0, obviously r is negative, a is positive. Let's do an example now of an exponential growth function using e. So here's the example, y equals 2e to the 0.6x. So to match this with our model that we discussed on a previous portion, we have a is equal to 2, so it's greater than 0, so it's positive. We have r, up here in the exponent, is 0.6, and that's greater than 0, so it's positive as well. So if a and r are both positive, that means we do have an exponential growth function. Now if we want to graph this, we can try x's 0 and x is 1 and see what our y value ends up. So when x is 0, 0 times this is 0. E to the 0 is 1. 1 times 2 is 2. When x is 1, we have e to the 0.6. And for that I'll have to use a calculator. So we'll take, we'll do that. Second e to the x, and we'll put in 0.6, close parentheses, enter. You get 1.822, and we multiply that times the 2. We end up with 3.644. 3.64 is accurate enough for what we're doing here. We know it's exponential growth, and we have 2 of its points. So let's see if we can rough out that graph. I'm just going to roughly make some divisions here. So 0 and 2 would put us here, and 1 and 3.64 would put us about there. And our asymptote would be the x-axis where y equals 0. So it looks like that. There's our graph. One additional thing that we can do with this graph is we can look and see what are the x domain values and the y range values. So when we look at this, we can see that x can go all the way out to negative infinity, and it eventually will get all the way to positive infinity in this direction. So the x domain, I'll put it over here, domain is all real numbers. Now as far as y goes, y approaches 0, but it never gets there. And it goes all the way up to positive infinity. So we can say that the y range, for that, y is greater than 0. So the domain is all real numbers, and the range is y is greater than 0.